Here we are going to learn how to find the probability of independent events. Here there are two boxes. First box contains 4 red balls and 5 green balls. The second box contains 4 red balls and 5 green balls. Here the first case, take 2 balls one after another without replacement. That is a one after. We are going to take 2 balls one after another. That means there are 2 draws. That is the first draw. After the first draw, we are not replacing that ball here. Okay, that is without replacement. Then here in this second case, there are two draw. We are going to take 2 balls. That means one after another. That is 2 draws are there, the first draw and second draw. Then is a with replacement. That means after the first draw, again we are replacing that ball the same place. Okay, because it's a with replacement, but in the first case is without replacement. Okay, then first we can check the probability in first case. After that we will move to the second case. We know in this case total how many draws are there? 2 draws are there, the first draw and second draw. Then we are checking first what is the probability of getting green ball in the first draw. What is the probability of getting green ball in the first draw? Total how many green balls are here? 5 green balls. Total number of balls 9. That means probability of getting green ball is equal to 5 over 9. Now we selected one green ball from here. Then is a without a replacement. That means we can't replace that ball here. Is a without replacement. Okay, then now the second draw. In the second draw case, what is the probability of getting green balls? Here how many green balls are there? 4 green balls. Total how many balls are there? Total 8 balls are there. That is probability of getting green ball is equal to 4 over 8. Now you can check the second probability. This second draw is depends on the first draw. That means these two events are dependent events. Okay, then the second case. This second case, total how many draws are there? 2 draws, because we are going to take 2 balls one after another. That is the first draw and second draw, because one after another, total 2 balls. Okay, then is a with replacement. Then the first draw, what is the probability of getting green ball in the first draw? Total how many green balls are here? In this case, total 5 green balls are there. That is 5 over total number of balls 9. The probability of getting green ball is equal to 5 over 9. Then this case is a with replacement. That means we have to replace this ball here the same place, because say with replacement. Okay, now the second draw, what is the probability of getting green ball in the second draw? How many favorable cases? Total number of favorable cases to which one? The green balls. Total how many cases are there? Favorable cases are there to green balls. That is 5 cases are there. 5 over. Then total how many cases are there? Total 9 balls are there. That is probability of getting green ball is equal to 5 over 9. Now you can check this one. The second draw is not depends on which one? The first draw. That means these two events are independent events. Okay, the definition of independent events. 2 events are independent if the occurrence of one event is unaffected by the occurrence of the other event. Okay, then this case, when 2 events A and B are independent, the probability of both occurring is, that is probability of A and B. What is probability of A and B? Is equal to probability of A times probability of B. That is separately find probability of A and probability of B, then multiply that two probability. That probability will get probability of A and B. Probability of A and B, or what is that one? Probability of A intersection B. To find in this case which one? If the two events are independent events, that case find which one? A and probability of A and probability of B separately, then multiply. That case we can find probability of A and B. Okay, that result, that is probability of A times probability of B. That result is the probability of A and B. So one problem. When Ganguly drives home from work, he has to pass through sets of traffic lights. The probability that the first set will be on red is 0.7. The probability that the second set will be on red is 0.6. That is, Ganguly drives from home from work to which place? Home. Okay, that is, he drives from workplace to home. Then he has to pass. Then when he are going to home, that time he has to pass two traffic lights. The probability that the first traffic light is red 0.7. Then the probability that the second set is on red is 0.6. Now from here you can check these two events. These two events are independent events. Why these two events are independent events? Because the first one is red. Is red or not red is not depends upon which one. The second event is not depends on which one, the first event. That means these two events are independent event. The first event, red or is not red, is not depends on which one, second one. Or second, this probability of second probability of which one, red, this second one is red 0.6. then what is the first one is red, that is 0.7. that is, these two events are independent event. Okay, that means when you are just read this part, then you will get idea. It's a clearly you will get the idea, because that one, the first one is not depends on which one, the second part. The second part is not depends on the first part. Okay, that means these two events are independent events. Okay, that means that here we have to calculate the probability that both sets will be on red. The next one is calculate the probability that neither set will be on red. That means the first one, question number A, that is both red. Both red means the first one red, the first traffic light red, and the second traffic light also red. That means it will come like this, the first red and second red. Now we know these two events are independent events. That means we can find the probability like this, probability of first red times probability of second red. Then what is the probability of first red? That is 0.7. then what is the probability of second red? That is 0.6. that means we can write 0.7 times 0.6, we will get the answer 0.42. The next one, calculate the probability that neither set will be on red. That means neither set will be on red means that neither red, that is the first one not red and second one not red. That is first probability of first not red and probability of and second not red. That means here we know these two events are independent events. That is, we can split this one, and by using multiplication law, that is probability of first not red times probability of second not red. Now this case we know probability of first red. What is probability of first red? 0.7. What is the probability of second red? 0.6. Then which way we can find probability of first not red? That is, this case we know the total probability. Total probability is equal to 1. From 1 subtract this 0.7, then we will get probability of first not red. What is that one? 0.3. Then which way we can find the probability of second not red? We know probability of second red. What is that probability? 0.6. The maximum probability 1. From 1 subtract this 0.6. That is, the remaining part is not red. That is, we will get the answer 1 minus 0.6. What is that answer? 0.4. That is, we will get the answer like this, 0.3 times 0.4. What is the answer? 0.12. The next problem. A fair coin is tossed and a fair die is rolled. Here there are two events. One is coin and other one is fair die. There are two things. Okay. Then find the probability of obtaining a tile and a 4. That is two events. That two events are find the probability of obtaining a tile and a 4. Now you can check this part. Probability of this one is coin and other one is die. Then here probability of obtaining a tile. Then other one is probability of obtaining which one? A 4. That means we know in tile case will we get 4? No, it will not possible. Die case, this tile and head, that part also not possible. Then that means these two events are independent events. That means this the occurrence of one event is not depends upon which one the occurrences of the other event. That means these two events are independent event. That means we can separately find the probability of tile and probability of getting a 4 and multiply, then we will get the answer probability of obtaining a tile and a 4. That is, we can write like this: probability of obtaining a tile and a 4 is equal to probability of a tile times probability of a 4, because these two events are independent events. Then what is the probability of getting a tile? We know in tossing a coin, that case total how many outcomes are there? Two outcomes are there. Then how many favorable cases are there to getting tile? That is one cases. That is one case. One case is there favorable to which one? Tile. That is 1 over, what is the probability of getting tile? 1 over 2. Then in this die case, if you roll one die, in that case total how many outcomes are there? 6 outcomes are there, because die case total how many phases are there? 6 phases are there. That phases numbered from 1 to 6. Then how many favorable cases for this one? This 4. How many cases are favorable to 4? How many cases are there? Only one case is favorable to 4. That is the probability of getting 4 is equal to 1 over 6. That means we can write like this: 1 over 2 times 1 over 6. You get the answer 1 over 12. Let's say this question we can do in another way also. We can do the same question. That means a coin tossed and a fair die is rolled. Then the outcomes are, these are the outcome, all possible outcome. Okay, then here you can check the one. What is T1, T2? T1 means tile, that is coin shows tile and die shows which one? 1. This one coin shows tile and die shows 2. That is T3, T4, T6. Then head, coin shows head and die shows 1. H1, H2. These are the all possible outcomes. Total how many outcomes are there? If we count, we will get the idea. 1, 2, 3, 4, 5, 6. Then here also again 6. Then total how many outcomes are there? 12 outcomes. The number of outcomes favorable to a tile and a 4. How many outcomes are favorable to tile and 4? Only one outcome is favorable to tile and 4. Then what is the probability of getting a tile and a 4? Is equal to 1 over 12. That's the answer, the same answer. This way also we can do this question. Okay. Thank you.